Welcome to the channel. The problem is given on the operational amplifier. Here, the circuit is given. Input is applied at the positive terminal of the operational amplifier. R1 is the feedback resistance, R2 is the input resistance, RL is the load resistance. Power across the RL is given, that is 10 milliwatt. Input voltage is given. Value of R2 is given. Value of RL is given, and we have to find out the value of R1. So let's see the basic of the operational amplifier. So this is the operational amplifier. Say this is positive, this is negative terminal. So positive terminal is nothing but the non-inverting terminal. Negative terminal is nothing but the inverting terminal. This is supply VCC. This is minus VEE supply. This is output voltage. So we are considering the negative feedback, and this feedback resistance is RF, and the input resistance we are considering, that is RI. If we apply the input voltage at the positive terminal, so this type of amplifier is called as non-inverting amplifier. If we apply the input at the negative terminal, so this type of amplifier we call it as inverting amplifier. So gain in the non-inverting amplifier is 1 plus RF upon RI when we apply input at the positive terminal. So this type of amplifier is called as non-inverting amplifier, and the gain is A is equal to 1 plus RF upon RI. So RF is the feedback resistance, RI is the input resistance. If we apply the input at the negative terminal, the gain in this case is minus RF upon RI. Feedback resistance divided by the input resistance when we apply the input at the negative terminal, and this type of amplifier is called as inverting amplifier. So in this case, only the load resistance is connected here. So this load resistance is RL. In this case, the load resistance is given RL, and which is at the output side. The power across the RL is given, and we have to find out the value of R1. So in this case, R1 is the feedback resistance, R2 is the input resistance, and whatever the value we are getting of the voltage across RL using power, which is 10 milliwatt, so the voltage across RL is nothing but the output voltage. So first of all, we need to find the output voltage, and from that we have to use the gain formula. That's it. So let's start. We know the power formula. Power is equal to I into V. But according to the Ohm's law, we know V is equal to IR. So in this problem, the voltage and resistance is given. So we have to convert the power formula in terms of V and R. So if you are putting this value in this case, instead of I, we can put V into V by R. So what we are getting? V square by R. So instead of current, V by R value is considered, and what we are getting? V square by R. Power is given in the problem, which is 10 milliwatt. This is equal to, this voltage is nothing but the voltage across load resistance, and which is nothing but the output voltage, since the resistance is connected at the output terminal. So whatever the voltage across the load resistance, that is nothing but the output voltage, and this resistance is nothing but the load resistance. So V0 square divided by the value of load resistance is given, and which is 10 kilo ohm. So after solving, 10 milliwatt is equal to V0 square by 10 kilo ohm. So we are getting V0 is equal to 10 volt. So this is about the output voltage, which is calculated from given power. Now let's calculate the exact value of R1, which is asked in the problem. In this problem, the input voltage Vi is applied at the positive terminal, that is nothing but the non-inverting terminal. So this amplifier is non-inverting type amplifier. You know the gain of the non-inverting amplifier. So gain is equal to 1 plus the feedback resistance is R1. In this case, input resistance is R2, and gain is nothing but the output voltage upon input voltage, which is equal to 1 plus R1 by R2. So the output voltage we calculated, that is 10 volt. The input voltage is given in the problem, which is 2 volt, which is equal to 1 plus, we have to calculate the value of R1, which is asked in the problem, and R2 is given 2 kilo ohm. So R2 is nothing but the input resistance, and which is given 2 kilo ohm. And from this, we can find out the value of R1, which is equal to 8K. So after solving this equation, say equation 1. So after solving, say equation 1, we are getting the value of R1 is equal to 8 kilo ohm. And this is the value which is asked in the problem. So R1 value is 8 kilo ohm. So this is the solution of this problem. Thank you.